So question 5 asks us to compare widths. So we could try to do this conceptually, which we can, but I know many times if you're just starting, it's a little nicer to actually compute them. So for each of the 4 options, I'm going to compute the width. Remember, width is 2 times the margin of error. Okay. So in choice A, with the confidence level is 79.76, then we do 1 minus 0.7996 as alpha, or how not confident we are as a decimal, we get 0.2004. And the confidence level is the same in A and B, so I'm going to have the same alpha. And in each of them, alpha over 2 is 0.1002. So to find z alpha over 2 for options A and B is the inverse norm of 1 minus the subscript. If I do that for both of them, I get a 1.28. Okay, and I'll do all the widths last. Why don't I get to the z alpha over 2's first? Okay, and choices C and D, when the confidence level is 99.96%, that means I'm 0.04% not confident. It's a 0.0004 for each of them, which means the alpha over 2 for each of these 2 options is 0.0002. And the z alpha over 2 is inverse norm of 1 minus the subscript, and that gives me a 3.54. Okay, so now if I want the width for choice A, it's going to be 2 times 1.28 times sigma divided by the square root of 250. Now, I don't know what sigma is, but I can multiply everything else, and I can get a 0.1619 times sigma, for whatever sigma is. Okay, for choice B, I also get a 2 times 1.28 for my 2 times z alpha over 2 times sigma divided by the square root of 50. So if I take care of all of the number parts, multiply these and divide by the square root of 50, I get a 0.362 times sigma. Okay, for option 3, or for option C, I'm sorry, I'm going to have a 2 times 3.54 times sigma over the square root of 200. And if I multiply these and divide by the square root of 200, I get about a 0.5. So this is about a 0.5 sigma. And for option D, if I do a 2 times 3.54, 2 times my z alpha over 2, times sigma over the square root of 250, if I do the multiplying and dividing, I get a 0.448. Of course, times sigma, for whatever value sigma may be. So if I'm looking for the smallest standard deviation, then for the smallest width, then regardless of what the standard deviation sigma is, the smallest multiplier in front is the 0.1619, which goes along with choice A.